Okay, in this video, we continue studying limits where x is approaching infinity or negative infinity. The examples that we do in this video are going to involve square roots. So before I get to the examples, I want to talk a little bit about square roots. Let's start by considering this equation. X squared equals 3. There are two solutions to this equation. X equals plus or minus the square root of 3. One of these solutions, the square root of 3, is positive. The other solution, minus square root of 3, is negative. So every positive number has two square roots, one positive, one negative. When we write the square root of a number, that always references the positive square root. If we want to reference the negative square root, then we have to put a minus sign in front to make it negative. So all of that should seem fairly elementary. Now let's consider this expression, the square root of x squared. So x squared has two square roots, x and minus x. Now when we write the square root of x squared without a minus sign in front, that means this is referencing the positive square root of x squared. So between x and minus x, which of these is the positive square root of x squared? Well, the answer is that it depends on x. If x is a positive number, then x would be the positive square root. However, if x was a negative number, then actually minus x would be the positive square root. So to emphasize this, the square root of x squared is equal to x if x is positive, but the square root of x squared is equal to minus x if x is negative. So this is going to be important in the examples that we do in this video. Before we get to the examples, just a small aside, if x is 0, then it doesn't really matter, so you can put equals here and here. Okay. Here we are going to consider the limit as x approaches plus or minus infinity of the square root of a polynomial over another polynomial. For these types of problems, your overall strategy is the same as what we saw in the previous video. You want to identify the largest power of x in the denominator, and whatever that power of x is, you want to multiply the numerator and denominator by 1 over that power. Now, for our examples, I'm just going to be working with some quadratic polynomials. And so there's going to be a subtle difference depending on whether x is approaching infinity or negative infinity. If x is approaching infinity, then that makes x a positive number. And so the square root of x squared would be equal to x. However, when x is approaching negative infinity, that makes x a negative number. So the square root of x squared would equal minus x, or equivalently, x would equal minus square root of x squared. All right, so I've got two examples set up right now. Both of them are the limit of the square root of 3x squared minus x plus 2 over 5x minus 4, but we have x approaching infinity for one and x approaching minus infinity for the other one. Now for both problems, we're going to start the same way. Identify the largest power of x in the denominator. So the largest power of x will just be x. So therefore, we're going to multiply the numerator and denominator by 1 over x. All right, so here, when we multiply these two together, I'll write it as the square root of 3x squared minus x plus 2 all over x. In the denominator, if we distribute the 1 over x, we're going to get 5 minus 4 over x. And it's going to be exactly the same over here as well. Now at this point, this is where I'm going to do something different for these two limits. In this first example, where x is approaching infinity, since x is approaching infinity, we can say that x is equal to the square root of x squared. So I'm going to replace this x here with the square root of x squared. I'm going to do the same thing over here as well. However, since x is approaching negative infinity, if x is approaching negative infinity, then I'm going to replace x with minus square root x squared instead, okay? So instead of writing x here, we're going to replace it with minus square root of x squared. All right. Next, I'm going to combine both of these into one square root. So we can write it all as the square root of 3x squared minus x plus 2 over x squared. Still just have 5 minus 4 over x in the denominator. Same thing over here. The only difference is we've got that minus sign here, which I'm just going to leave in front of everything now. Okay? And we're almost done. Next, I'm going to divide x squared into each term here. 3x squared over x squared is 3. X over x squared is 1 over x. Then we've got 2 over x squared. Now we're going to plug in infinity for x. So remembering how a finite number over infinity is 0, we're going to get 1 over infinity, 2 over infinity, and 4 over infinity, which will all be 0. So we're going to be left with the final answer of square root 3 over 5. And you can do the exact same things over here. Only difference is since we have this minus sign that's just hanging out in front, at the end, you're going to end up with an answer of minus root 3 over 5 instead. Okay? Now let's consider if we have the limit where x is approaching infinity or negative infinity of a polynomial over a square root of a polynomial. This is a little bit different from the previous examples in that the square root is now in the denominator. So it's going to work fairly similarly. What we're going to do is start by identifying the largest power of x in the square root. And whatever that power of x is, we're going to multiply the numerator and denominator by 1 over the square root of that power. So we'll see that in action when we do the examples below. And again, there's going to be a small difference between whether x is approaching infinity or negative infinity. To start with, in the denominator inside the square root, the largest power of x is x squared. So we're going to multiply both the numerator and the denominator by 1 over the square root of x squared. That would be the same over here as well. Now, before I multiply any of these together, what I'm going to do is I'm going to rewrite this square root of x squared as x. And so in this example, the square root of x squared equals x because x is approaching infinity, meaning that x is positive. Here, I'm going to leave it as the square root of x squared. And in this example, I'm going to again rewrite this square root of x squared. But this time I have to rewrite it as minus x instead, because x is approaching negative infinity. All right. So now we can distribute this 1 over x. That will leave us with 6 plus 5 over x. Here, we're just going to get the square root of 4x squared minus 3x plus 2 over the square root of x squared. Whereas in this example, we're going to get the same thing. We just have this extra minus sign, which I can now just keep writing in front of everything. So here you can kind of see at this point that it's going to work out similar to before, and that we're going to get the same answer, except this one's going to be opposite sign of the answer over here. So now I'm just going to work on this example. Again, we can combine these two into a single square root. Next, we can divide the x squared into every term. And finally, when we plug in infinity for x, 5 over infinity, 3 over infinity, and 2 over infinity are all 0. So we would be left with 6 over the square root of 4, which is 6 over 2, for a final answer of 3. And you can do the exact same thing over here. But because of this extra minus sign in front, that means you're going to get a minus 3 in the end for the final answer. Okay? All right, so that's it for this video. Thanks for watching.